Right. I want you to imagine a scenario with me. It's it's really the absolute worst case for anyone working in IT operations. I mean, it creates a physical reaction just thinking about it.
I'm already nervous.
So it's Saturday afternoon. You're the lead IT admin for Contoso Corporation. You're maybe 3 hours away from the office visiting your in-laws for a long weekend. And you consciously decided not to bring your work laptop because, you're burned out, you've been on call for a month, and you deserve a break.
That is a dangerous game to play. Those are famous last words right there.
Oh, I know. And of course, the universe punishes you immediately. You're in the backyard, spatula in hand, flipping burgers, and your phone just blows up. It's the lead developer. A mission-critical virtual machine, the finance app, has gone completely dark during a routine maintenance window.
And let me guess, because of your strict security posture, the developers don't have the permissions to restart the underlying infrastructure, so they're totally locked out.
Completely. It is 100% on you.
Uh,
So panic sets in. You have no VPN, no admin workstation, no SSH keys, no scripts. All you have is your brother-in-law's laptop, which is, I don't know, covered in some inexplicable sticky residue and running a browser with 50 open tabs.
Yeah, 10 years ago, that's a drive 3 hours back to the office situation. Or at least you're scrambling to install a VPN client on a compromised machine, which is a whole security nightmare in itself.
But not today. And that is the setup for our deep dive. We are looking at two massive pillars of modern Azure management that solve this exact problem. First, the tool that saves your Saturday in that nightmare, Azure Cloud Shell.
Right, the ability to manage literally everything from a browser.
And second, the whole methodology that prevents that server from breaking in the first place, infrastructure as code, and we'll be looking specifically at ARM templates.
It's a great pairing, really. One is your Swiss Army knife for the emergency, that's Cloud Shell. The other is your blueprint for long-term stability, and that's the ARM templates.
Let's start with the emergency. We've got these sources, Introduction to Azure Cloud Shell and deploying infrastructure with JSON ARM templates. So what exactly is happening when I grab that sticky laptop and log into the Azure portal?
So, historically, if you wanted to manage Azure from the command line, you had to prepare your whole environment. You'd have to download the Azure CLI, install the right PowerShell modules, make sure your Python version was correct. It was a whole setup process.
And if you're in a borrowed laptop or, I don't know, a hotel kiosk, you can't just start installing admin tools. You
Yeah.
don't have the rights, and you certainly don't have the time.
Exactly. Azure Cloud Shell just flips that entire model. When you click that little terminal icon in the portal header, it looks like a little command prompt symbol. Microsoft is dynamically provisioning a temporary compute host for you. It's a containerized environment that just spins up on demand instantly.
So wait, just to be crystal clear, it's not running in the browser. It's not using my brother-in-law's CPU to process all these commands.
No, the browser is just the window. The actual execution is happening on a Linux machine that Microsoft manages in their data center. And the killer feature here is that it's authenticated automatically. Because you're already signed into the portal, the shell just inherits those credentials. You can type as VM restart and it just works. No as login, no extra two-factor prompts.
And that right there, that's the zero setup, promise the source material really emphasizes. But I have to ask, if Microsoft is the one managing this whole image, do I get any say in how it works? Or am I just, stuck with whatever shell they think is best? I know some admins are diehard Linux people and others, well, they bleed PowerShell.
Oh, absolutely. You have a choice. Yeah.
Yeah.
There's a toggle right at the top of the terminal window. You can drop into a Bash environment if you're coming from a Linux background, or you can switch over to a PowerShell environment if you're a Windows admin. It totally respects your workflow.
Okay, but here's the catch I'm worried about. You said this is a temporary host. So if I'm in the middle of this crisis and I write a quick script to diagnose the VM, or maybe I upload a specific SSH key to jump into the box, and then my internet flickers, or I accidentally close the tab, is all of that just gone?
If it was just the container, yes, it would absolutely be gone. That's what we'd call the persistence problem. But Azure solves this with something called the Cloud Drive.
Okay, so how does that work?
The very first time you launch Cloud Shell, it'll pause and ask you to mount a storage account. It effectively takes an Azure file share and mounts it directly into your session as a drive.
So it's kind of like plugging in a USB stick, but the USB stick is just in the cloud.
That is the perfect analogy. Anything you save into that home directory or the Cloud Drive folder is physically written to that Azure file share. So the compute container dies when you log off, but the storage persists. You could start a script on your brother-in-law's laptop, save it, drive home, open your work laptop, fire up Cloud Shell, and that script is just sitting there waiting for you.
That's huge for continuity.
Yeah.
It's basically creating a roaming profile for all your admin tools.
Now, speaking of writing scripts, I'm picturing a command prompt. And I'm not exactly keen on writing complex JSON or, Python and Vi or Nano if I can help it. I mean, I respect the people who do, but in a crisis, I want a mouse.
Right. Well, you don't have to be a Vim wizard to use this. Cloud Shell actually includes a built-in graphical editor. It's based on the open source Monaco editor, which is the exact same thing that Visual Studio Code is built on.
Wait. So I have VS Code inside the browser terminal.
A lightweight version, yes. If you type code dot in the terminal, or you click the little curly brackets icon, it splits the window. You get a file explorer on the left and a proper text editor with syntax highlighting, IntelliSense, multiple tabs on the right. You can edit your ARM templates or your PowerShell scripts right there above the command line. That bridges the gap significantly. It's not just a terminal. It's a legitimate little dev environment. And looking at this software list in the source notes, it's stacked. I mean, I expected Azure CLI and PowerShell, but I'm seeing Docker, Kubectl, Helm.
It's designed for the modern cloud engineer, really. It's not just for restarting VMs. If you're managing a Kubernetes cluster, Kubectl is pre-installed. If you need to build a container image, Docker is there. You've even got MySQL and PostgreSQL clients if you need to query a database.
I even saw Terraform and Ansible on the list. That surprised me.
It is incredibly powerful, but that's also where we need to apply a little bit of nuance. This is the pro tip area, let's say. Just because you can run Terraform from Cloud Shell doesn't mean you always should.
Why is that? I mean, if the tool is there, why not use it?
Well, think about state files. Terraform relies on a local state file to know what it built, right? So if you run Terraform apply in Cloud Shell, that state file gets created in the container. Now, if you didn't configure a remote backend like storing the state in a storage account and that session times out,
you lose the state file. And Terraform has no idea it manages your infrastructure anymore.
Exactly. And now you have orphaned resources that you have to manually import. It's a total mess. So while the tools are there, you have to be really conscious about how you use them in an environment that's temporary.
That brings us right to the limitations. The source material is pretty clear that Cloud Shell is not a replacement for, say, a dedicated management server for everything. It has its boundaries.
Right. And the biggest one is the timeout. This is an interactive shell. It's designed for you to be typing in it. If you stop for 20 minutes, the session times out and the container just spins down.
So I can't kick off a massive data migration script that's going to take 4 hours and then go back to my burger.
Absolutely not. It will die somewhere in the middle, and you won't even know where it stopped. It's for ad hoc interactive tasks. Also, you don't have root access to the box. You can't run sudo apt-get install to add some obscure library. You have to work with the tools Microsoft gives you.
And what about managing multiple clients? If I'm a consultant, can I just have 5 shells open at once?
Nope, it's a single session per user. You can't open 20 tabs of Cloud Shell to manage 20 different tenants. It's just one shell for your one login.
So to kind of summarize the Cloud Shell piece, it's the ultimate James Bond tool. You get in, you have all your gadgets, you fix the problem, and you get out.
Exactly, it's tactical.
But here's the thing. If I'm spending every Saturday using Cloud Shell to fix broken servers, I have a bigger problem than just access. I have a stability problem.
You have a configuration drift problem.
Right. And this is where we pivot to the second part of our deep dive. We're moving from fixing things manually to defining them automatically. Infrastructure as code.
This is the big mindset shift. In the old days, we treated servers like pets. We gave them names. We nursed them back to health. In the cloud, we want to treat them like cattle.
And the way we do that is by defining them in code. The source material here focuses really heavily on Azure Resource Manager templates, or ARM templates.
Right, and ARM templates are the native language of Azure. They let you define the state you want, a VM, a storage account, a network all in a text file. You send that file to Azure, and Azure's job is to make it a reality.
Okay, there are 2 key concepts the authors harp on here: declarative versus imperative. I feel like these terms get thrown around a lot in tech, but let's nail down what they actually mean for the admin on the ground.
Sure. Think of imperative as a script. PowerShell is usually imperative. You are telling the computer how to do something step by step. Step 1, check if a network exists. Step 2, if not, create it. Step 3, wait 30 seconds.
It's like a recipe.
It's exactly like a recipe. And if one step fails, or if the network already exists and your script doesn't handle that error gracefully, the whole thing can crash. It's brittle.
Okay, so then Declarative.
Declarative code, which is what ARM templates are, is totally different. You don't list the steps. You just describe the end result you want.
More like ordering a meal from a menu.
Perfect. You tell the waiter, I want a steak, medium rare. You don't go back to the kitchen and tell the chef how to light the stove, what temperature the pan needs to be, or how long to sear each side. You declare the outcome, and the chef, in this case the Azure Resource Manager, figures out all the steps to get there.
And this leads to that wonderful fancy word in the source text, idempotency.
Idempotency. It's fun to say, but it's so crucial to understand.
So what does it mean in practice? Why should I care about it?
It means you can run the same template against the same resource group 100 times, and you will get the exact same result without errors and without creating duplicates.
So if I deploy a template that says create a storage account, and that account already exists.
Azure just looks at it and says, oh, this matches what you want, I'll do nothing. Or if you changed a setting in the template, say you change the storage type from standard to premium, Azure it just says, the resource exists, but it needs an update, and it applies only that change.
That creates a huge safety net. I don't have to write all this complex if-then logic in my scripts. I don't have to check if something exists first.
Exactly. It simplifies the logic and it guarantees consistency. It means you can deploy with confidence, knowing you won't accidentally delete something or create a, copy one of your production server.
Okay, let's get into the weeds a bit. The source material focuses on JSON templates. Now, I know JSON can be, well, a little particular, all those curly braces everywhere.
It is a strict format. It's JavaScript object notation. And yes, missing a single comma can ruin your entire day. The text does mention bicep as a newer, simpler language that abstracts a lot of this, but it insists that understanding the raw JSON is foundational, because that's what Azure ultimately reads under the hood.
So what does this file actually look like? If I open one up in that Cloud Shell editor, what am I seeing?
It has a pretty standard skeleton. You've got the schema and version at the top, but the meat of the file, the important part, is the resources section. This is where you list the actual objects you want to build.
So it looks something like type Microsoft.compute virtual machines, name, web server, location, East US.
Precisely. But this is where beginners get into trouble. If you hard code everything, if you literally type East US and web server directly into the resource section, that template is what we call a snowflake. You can't reuse it.
Because if I then try to deploy it to a West Europe region, I have to go in and manually edit the file. And manual edits are where typos happen.
Right, and that breaks the whole write once, deploy many philosophy. So to fix that, we use parameters.
Parameters are the inputs.
Yep. In the parameter section of the template, you define a bucket called location or server name. Then down in the resources section, instead of writing East US, you write a little piece of code that says parameters location.
So when I run the deployment command, it'll actually stop and ask me, hey, what do you want the location to be today?
Exactly. Or your automated pipeline just fills that in for you. This lets you use the exact same template code for development, for test, and for production. You just pass in different parameters.
Now, the notes highlight a specific type of parameter called secure string. This seems absolutely critical for things like passwords, but I wanted to understand how it works. If the JSON file is in my source control, isn't the password still visible?
That is the most important question to ask. You never, ever hard code a password in the JSON file. You define the parameter as a secure string. And this tells Azure two very important things. One, do not echo this value back to the screen when I type it. And two, do not save this value in the deployment history.
Wait, deployment history?
Yeah. Every time you deploy something to Azure, the portal keeps a record of all the inputs. If you used a normal string for a password, any admin could go to the portal, click on Deployments, and see the admin password in plain text. Secure string prevents that. It masks the input everywhere it can.
That is a massive gotcha if you don't know about it. Wow. There's another feature in parameters that caught my eye. Allowed values. It feels like a way to prevent junior admins or, tired senior admins from making really expensive mistakes.
It's basically a bouncer at the door of your deployment. Let's say you have a policy that developers can only use small, cheap storage accounts. You don't want them accidentally spinning up some massive, expensive geo-redundant database that burns through your entire budget in an hour.
So in the template, I can actually list the specific options they're allowed to pick.
Yes. You define allowed values and you list standard LRS and standard GRS. If someone tries to deploy premium ZRS, the deployment fails validation instantly. It doesn't even try to build it. It just says, nope, not on the list.
That's proactive governance. I love that. It stops the error before it costs money. So we have Resources, which is the what? Parameters, the inputs.
Well,
Let's talk about outputs. Why would I need the template to tell me anything back? I already know what I built.
well, think about automation chains. Let's say your template builds a new storage account. Azure generates a unique endpoint URL for that account. You don't know what that URL is until it's actually built.
Okay, yeah, that makes sense.
But maybe the next step in your automation needs that URL to configure a web app to talk to that storage. Instead of making a human go into the portal, find the URL, and copy-paste it, the template can just output that value directly.
So the template finishes, and it effectively passes a note to the next script saying, hey, here's the URL you're going to need.
Exactly. It lets you chain deployments together seamlessly.
So we have our JSON file. It's got resources, parameters, and outputs. How do we actually pull the trigger? We're back in Cloud Shell, I assume.
We are. You would typically use the Azure CLI. The command is as deployment group create.
The notes mentioned there was an older command, right? As group deployment create.
Yeah, the wording was swapped. As group deployment is deprecated now. You want it as a deployment group. It's a subtle shift, but it's important to stay modern. You just point that command at a resource group and your template file, and off it goes.
So let's try and synthesize all this for the listener. We started with a panic on a Saturday.
The worst kind of Saturday.
We used Cloud Shell as our immediate tactical response. It gave us a secure, authenticated zero setup environment to troubleshoot and fix the issue right from a browser.
That's the Fix It Now tool.
But then we realized we don't want to live in Fix It Now mode. We want stability. So we adopted infrastructure as code using ARM templates. We made our infrastructure declarative, idempotent, and version controlled.
And that's the Build It Rate tool.
It really seems like you can't be a modern cloud admin without both. If you only know the portal, you're slow and you're error prone. But if you only know Terraform or ARM and you can't troubleshoot a live issue, you're kind of helpless in a crisis.
That's a fair assessment. Cloud Shell gives you agility. ARM templates give you reliability. You need the Swiss Army knife, and you need the blueprint.
I want to leave you with a thought that really struck me while reading about the capabilities of Cloud Shell. If we are moving to a world where we declare what we want via code with ARM templates, and we can trigger those deployments from a browser on literally any device using Cloud Shell, are we moving toward a future where the whole concept of the admin workstation is obsolete?
It connects to the bigger picture of the thin client making a comeback. If all the compute is in the cloud, both the infrastructure you manage and the tool you use to manage it, why do you need a $3,000 laptop with 64 gigs of RAM?
Maybe that sticky laptop with the burger grease on it is the future of enterprise IT, after all.
Let's hope for better hygiene, but yes, the hardware matters a lot less than the credentials and the code.
A fascinating shift. Thank you for listening to this deep dive into Azure management. We hope you feel a little more prepared for your next on-call weekend.
Stay curious and keep automating.
We'll see you on the next deep dive.